Yeah, as Klaus already announced, we will talk today a little bit about how to save space in the control cabinet. First of all, I give you a short introduction of myself. My name is Frank Polley. I'm working since 35 years with Weidmuller. That's the reason why my professional performance on connectivity is definitely there. I learned there a lot, but also processing and workshop and digital data continuity. I have a good experience inside. And why I talk today about this space saving topic with you is because this is part of our connectivity consulting job. We are always asked when a customer want to optimize his workshop or his cabinet in terms of more efficiency, in terms of the space saving, in terms of all this stuff. They call our sales, and our sales will call us. So in case you have the same demand, you need some optimization advice with regards to efficiency or with regards to space saving, do not hesitate to contact your local Weidmuller sales or contact me directly by the email address you see here. For sure, you can also check my LinkedIn profile and go to visit us in Hanover. Yeah, this is a small advertisement in our own perspective. Now let's have a look first of all about the initiative. Most of you will know this is a consortium of customers around the control cabinet building with the mission to make more digitization and automation in the control cabinet building. Yeah, the workshop is still a lot of manual, but under the headline of skilled labor reduction and cost efficiency. Those companies work together, which you see here, to make your workshop, your design, and your digital data continuity to bring this on the next level of automation and digitization. Yeah, you see the companies here, and the person you see on the picture I will introduce at the end of the presentation. Yeah, the headline of the today webinar is it's getting tight in the control cabinet. And talking about this, I will switch off my camera because I get the signal that otherwise the transmission will get maybe interrupted. So let's talk about the space saving in the control cabinet building, and everything starts at the beginning for sure at the famous digital twin, the very well over-squeezed name, because in the design phase and in the construction phase, you have for sure the best possibilities to reduce space. That's the reason why for sure in the design phase of a control cabinet, you lay the bricks for the right dimensioning of the control cabinet. The today webinar will be split in 4 parts. I will introduce you the 4 steps we are doing, which we developed for ourselves in my team, Connectivity Consulting, which we are using to reduce the space at our customer cabinets. I will give you a short view into the machinery room of our work, and this hopefully helps you with your own projects. You are running your company, and just a small view of some cabinets which we have already consulted. This is a very small topic, and you can see most of the cabinets are already very full with functionality and with equipment out of the electromechanic, out of the electronic, with frequency drives and safety controls and all this stuff. At the end, the space for the cabinet is always in many cases be defined by a machine designer, by a architect for the building. So the footprint of the complete equipment is predefined, and when you now have such filled cabinets and need to implement more functionalities because you need to have more functionalities of your machine, then you will always go to the loop and check, okay, how can I make this? And this was the same approach which this customer contacted us. It's a customer from Austria, OEBG, and they have this panel you see in the middle of the picture. And this customer asked us, hey, how can I implement this control cabinet, which is currently standalone? How can I implement this control cabinet in the machine corpus so that I have a lot of benefits with my machines? I will explain later on. So this was one example of the challenge. And this challenge we meet with this 4 steps model. And let's start direct with the first step. And I've chosen this picture because it's the symbol that you first of all have to clean up or throw off ballast. Yeah. So you have first step in your electrical cabinet. You check what is redundant and where you can save space by cleaning up. Yeah. How we are working is first we have a view because we feel very familiar with this. As you can imagine with Weitmüller, we have a look on the terminal rails and we checked how many terminals are equipped, installed, and how many are rewired, because we know that in a lot of customers, due to former standardization and optimization process, there is some reserves installed where you have empty terminals which are saved for options. And we frequently ask if this is still today necessary or if the functionality is maybe replaced by other topics. Then the next thing we check in our first case is check redundancies. And a very simple thing, just as an example, is that we check if there is a ventilation inside the control cabinet, or maybe even a heating, if the temperature sensor could not replace by a functionality which is built up electronical. For example, in our U-remote system or in any other I/O system, because in many cases I/O systems have more inputs and outputs on board as the application really needs, and then we can suggest in this case that, for example, this device could be replaced by an electronical function which is already available and which then could be used. Then we check functions. We check which functions are on-site the rail and how we can solve these functions different, like the famous plug socket for power, which you see in most of the cabinets as the service technician asked for. There is a solution to get them from the board of the cabinet into the wall. Yeah, by, for example, this nice plug-in box, which is closable for the service technician. So it's not accessible in standard place, but the service technician will have a key and can have access, and this will space a small space. And also we check functionality and formal standards. Yeah, from formal standardization, customer may implemented 4 changeover relays like you see on these pictures. Yeah, because they say, okay, I have only 1 relay which I use for all the application, and the 4 changeover relay can solve a very lot of. It's a little bit the Leatherman of the relays. You can solve a lot of applications. But when you look in detail, you see that only 1 contact is wired. Means that the customer install not using 4 contacts, 3 contacts out of this 4, but will spend the way the space in this cabinet. And just to make it a little bit more visible, here's a small calculation. When you start, when you have saved a 4 changeover versus a 2 changeover versus 1 changeover, you can save up to 75%. Yeah, so this is space saving you can do, and if you have more relays, for sure you save more. If you have small relays, you save small, but this is also valid for conductors, fuses, and other power switches. Check the real demand, which brings me to the next point, the dimensioning. Yeah? We come from a world, when you see this glass of water, you will may ask yourself, hey, is the glass empty, half empty, or is it half filled? My answer is the glass is too big. Yeah? If you have only this level of water, you can take a smaller glass, and this is what we mean with dimensioning. Yeah? Ask your components, ask if this is really the right volume you need. For sure, we look, for example, on power supplies. As you see here, when you're choosing instead of a 10 amp hour supply, a 5 amp hour supply, you can reduce the space from 60 to 40 millimeters, and this is space saving of 30%. Very big value. What you can also check in regards to dimensioning, if you have already a cooling in place, and you go to your power components, then you can check if your cooling support you with the airflow, and with a stronger airflow you might can reduce the space you need to keep between the modules and between the distance, so that you can take the reserve out of this devices by dimensioning. Another topic which I always address, and this is very important, take care on your standards. Yeah, by all the optimization, by all the reduction, by all the cleanups, you have to consider for sure the standards. You have to check thermal topics, not heat up the devices. You have to look on EMC topics. And for sure considering also standard design rules in control cabinet, like separation of power and control. So this should be always be in your check loop, and I will address this a little bit later. Yeah, one top tip at that point. If you go to a 3D planning, like with the Zuken E3 tool, you can use that tool to help you with the optimization, because with the collision control, you can take also out some space and check if the new design you have planned is also assemblable and suitable for the practice. This is also a small step to help you at that point. Another step which I want to check in detail is a little bit more on the next slide, is the reduction of the wire diameter. As the power consumption of a lot of consumers getting down due to power saving rules, maybe also the wire diameter can be reduced, and this brings then the possibility to go maybe from a 2.5 square millimeter to 1.5 square millimeter diameter, and on the paper this would save 30% space. How this could look like in practice, we see on the next slide. Yeah, this is a slide this is a terminal rail we have taken from a customer out of a customer cabinet, and rebuilt this DIN rail, which is nowadays around about 450 millimeter long. We rebuilt this functionality with a 1.5 millimeter square diameter, and this reduces space at this customer by 25%. Why not 30%? Because there are always components inside, like end brackets, end plates, or other devices which are simply not reducible. Yeah, this is not going linear. This is going always hand in hand. That's the reason why 25% is a good value. Okay. This was with regards to the cleanup and dimensioning story. So we are now through the phase where we where we reviewed and where we checked all the existing values, and then now it's time for setting new standards. And when we at Weitmuller talk about new standards, we are looking very close to the application of our customers. And at that point, particularly on the application sheets of your circuit diagram, and the circuit diagram in many customers is built up in the structure that you have a power feed in a distribution part, you have a control voltage generation as distribution, and then you come to the signal wiring, and then later on also the power part. So this is a standard structure of a design. Circuit design of a control cabinet, and this is the structure we will have now a closer look to, where we can optimize a control cabinet with using these new standards optimized for the particular application fields. Because you can imagine, if you take, for example, the same terminal for power feed in than for signal wiring, then you will optimize, or you will orientate the size and the diameter of the terminal always according to the power feed in part, maybe a 4 or maybe 6 millimeter square, and the signal requirement maybe only requires an 0.75 or 1 square or even 1.5 square millimeter diameter. So you see the conflict. So we would invest in too much space in that part. Again, we are talking about space saving. Yeah, this is a particular view on this today webinar. Yeah, and as I mentioned, when you review and refocus your idea of standardization to that application field, then you will find that there are some solutions in the market which give you new possibilities, and I will show up some of this here in the next pages. So when we're talking about power feeding and power distribution, one possible space reduction is to the use of a complex, not a complex, but a compact a power block like our WPD terminal block. And you see the comparison from a traditional power distribution feed-in to the WPD block compared by different diameters we put in and we feed out. And this usage of the WPD has around about 25% space saving. And what you see here in this block is just one phase out of the custom application we have taken. But you can imagine that when you have this one phase by three phase, by neutral and by PE, then you have also quite reasonable space saving also in this application. Yeah. Another application product would be control voltage distribution, what we are frequently looking at. A lot of customers using 4-wire terminals for this power distribution. So in this block, in this first block, they have the minus potential feed in, and then they have the minus potential here, and then they have the different 24-volt voltage, 24-volt circuits here separated in these blocks. And this block we rebuilt by a new alternative. We're using our so-called AAAP terminals. These are power distribution terminals with a different setup, partly including fusing. You see that here on the right picture. And this gives you the possibility to save space up to around about 20%. Yeah, we're considering the feed-in terminal and also the end brackets are still there, and also the end plates still need some time. So the net saving of this solution is definitely around about 20%. Just as an idea how you can solve this with application oriented product. Another solution in the control voltage distribution is the implementation of so-called electronic load monitoring, like our MaxGuard. We see in a lot of cabinets that due to standardization, the power fusing is used by thermal circuit breakers, like you see on the left picture. But for 24-volt DC, this circuit breakers are not that useful, because they will be in many cases too small. You have to consider certain rules that this thermal circuit breaker will protect the 24-volt DC, and at that point comes in the electronic load monitoring like MaxGuard. And in our MaxGuard, you have also implemented the power distribution, as you can see on the red and the blue buttons for the pusher. And this is a double time space saving. So you reduce space because you use, instead of an 18 or a pitch thermal fuse and 6 millimeter pitch thermal fuse, plus you have implemented the power distribution direct on the block. And this, from the practical experience from the more than 300 projects we have considered in the meantime with this solution, we have a minimum space saving of 50% in this application. As I mentioned, the MaxGuard load monitoring also fulfill the requirement according to the IEC 61131. Which asks the power supply not to have a voltage drop bigger than 10 milliseconds. So in this time, the 10 milliseconds PLC will keep the power up. But once the power shutdown is longer, then the PLC will also shut down. And with a MaxGuard or with an electronic load monitoring, you can keep that time requirement. Another option is that a lot of customers wire up their sensors direct in the panel, and you see here on the upper level a typical DIN rail we see in those customers. You have different. You have here the concrete the sensor block. You have here at that point the actor block, and then you have here in front of the power distribution, partly even with PE terminals. And you can solve this much smarter and more space saving with so-called AIO terminals, which are terminals which have the power distribution plus minus included, and then the signal is handed over. The benefit besides space saving of these terminals is that you not just have 50% safe spacing when you view on the footprint. It's not just the length of the terminal array, but also the depth of the terminal array. For sure, this kind of terminal is a little bit deeper. But the benefit is that you have also wiring benefits. Yeah, we have a clear wiring direction. When you imagine that you come from the bottom here and wire up your sensors, you have a lot of, for sure the sensor wires are clearly orientated, but the plus minus wire are frequently going around the terminal or even crossing the terminals. We see there are a lot of different creative solutions in the field. And this is different solved here because you have per sensor one terminal where you can put in connect plus minus and also the sensor signal. Yeah, and this is how it looks like in reality in the 3D form. So you can have a better idea of this. And this again save up to bigger than 50% of the space. The same story with dedicated motor terminals. We have one certain series of motor terminals where you can save space up to 40% by not using standard feed-through terminals, but certain dedicated terminals for the motor connection, like you see here on the pictures, 3-level. And again, we always have to consider the footprint because you have always to calculate with lengths and deeps. But we found in many customer cabinets that there are components with a bigger space, like power supply or I/O slides or other topics where this motor terminals fit perfect in. Yeah, and now we have go through 3 steps. We cleaned up. Yeah, we are checking the dimension. We check if the glass is maybe too big. We set new standards, and if this not helps you to clean up or to reduce the component, the space in the cabinet, then the last remaining step is decentralization. And you see and on this picture, you can see that decentralization has something to do with waterproof and can also make fun. So this is what I want to have a look on in the next following slides. We have again the same structure: power feeding, control voltage distribution, and for your better orientation, we have also the symbols here. One example for space saving in the control per cabinet is the outsourcing of the power feed in and switch on circuit. We have here our so-called Fieldbauer box with a maintenance switch, and this enables you to contact the power wire direct with an IDC connector, and out of this you can get a power distribution up to 3 circuits to the field where you can connect other devices. So you can take the power feed in and power distribution out of the control cabinet down to the field, down to the machine, maybe even closer to the power feed in cabinet of the complete hall and facility. Another topic is another possibility is to generate a 24-volt DC, the auxiliary power supply external with this decentralized field box for 24-volt DC. This has included the fusing inside. This is a power supply included. You can go in with 230 volt and distribute via the plugs the 24-volt DC to your dedicated devices in the field, to your sensor hubs to the pneumatic valves, stations, and so on and so on. So you can take the complete 24-volt DC generation out of the control cabinet and put it into the field in case you have in any case you want to save the space in the cabinet. And when we have now already the power distribution and the 24-volt DC generation out in the field, we can make also the signal collection in the field with this, I guess, well-known in the meantime, M12, M5, M8 connectors, and with all the pluggability around that. So this space saves some space on the terminal rail in terms of sensor actor connection. And for sure, this is also available as an active version where you then have maybe, for example, the I/O system direct in hand. Also partly not known is that this M12 World is also available with a power version, which can handle 230 volt. Most of the customers think that M12 World can only be used for 24 volt DC and signals. No, there's also power versions available, which could handle up to 4, 5, 6 amp. Which are very useful which could be used for a lot of power application, motor distribution, valve connection, and so on, wherever you need 230 volts. So you see that out of this power feed-in, auxiliary power generation, signaling, and also the load switching, you have a lot of decentralized possibilities. And this brings me back to our smiling customers, and as you can see here on the pictures, we were able to implement the complete control cabinet, which you see here on the right side of the pictures. We implement the complete functionality of this control cabinet with this method, with these 4 steps into the machine, and this has not just space-saving benefits for this customer. This customer has also benefits with regards to the ramp-up, because normally he ships the machine and the cabinet separately. So the ramp-up time, he need to wire the cabinet, he need to ramp the cabinet up. This takes time out in the field. And with this concept, he had implemented the control cabinet in the machine and then power the machine up and ramp them up, with including pre-testing in his facility. So he has not just saved space, he has also a lot of benefits. Plus, he has saved also space in the shop floor of his end customers, and this makes the customer really happy, because now he is again more competitive as his competitors, and looking forward to receive some or at least a lot of new orders. Now you will come to the point that you say, hey, Frank, this is very nice storyline telling, but I guess your solution will be more expensive. And I can tell you no. Because when we look in detail, what have we done? First step, clean up, throw off ballast. Definitely this is money saving. Whatever functionality you not need in your cabinet, you can take out, it will save you money. Second part is dimensioning. When you buy smaller dimension components, you normally, in normal case, save money. When you buy, instead of a 10 amp power supply, a 5 amp power supply, the 5 amp power supply by definition should be cheaper. When you implement the new standards, as I've shown you on the pages, the material you invest will be the same amount of money, so there will be no extra money. So this will be neutral. The only fact where the cost may go up is the decentralization, because for sure, if you take single functions out of a protected control cabinet and put them into decentralized small boxes, you have more boxes, you have more material, you have more isolation, more effort in that, and this will for sure bring the cost up at that point. But what we see also in our project, that when you consider this famous TCO, this total cost of ownership, and also considering the installation cost and the other benefits which is coming out of the decentralization. For example, less assembly time by using plug connectors, less failures by using plug and play solution, by coded plug and play solutions. All of this time saving. When you put this into the same calculation, you will see that also the decentralization could end up at least in a cost neutral position. And calculating all this together, the sum of these measures will be in most cases reduce not even just the space of the cabinet, but also reduce the cost of the cabinet. Yeah. And one remark from my side, and this is a graph from out of the lean world, the lean management methods, which we are also using at our customers to optimize the values chains in their workshops. Not do all at once, make continuous improvements. You see here the famous, or maybe known PDCA. Circle, plan, do, check, act. And this means you plan an activity, then you do it, and then you checked, and then you follow up if the result you planned at the end of the day really is coming. And when you do such an optimization of panel reduction, you should do not all at the same time, because if you throw out components, if you change the dimension, and if you maybe go even to decentralization in the last step all at the same time, and you have at the end of the day then some errors and some mistakes because you have not considered all the effects from the beginning, then you will have a very big throwback at that point, and will start normally at the starting point. So our proposal is, and this is the best practice I can give you on hand, do small stack at that point. Maybe definitely start first with a cleanup, and after you have finished that, then check which dimensions you can change. Then check this, implement this, and then go step by step. And what this has to do with smart cabinet building network, where you dial in today, definitely for sure, we not just want to digitalize and automate your value chain. We also want to optimize your business in total, and that's the reason why we frequently give in this so-called little work hacks, where we bring in then the component knowledge from Weitmuller, which is definitely there, together with all the other knowledges of our partner networks in the control cabinet building sector. And yeah, so this makes, for example, as mentioned, using a 3D cabinet design tool will help you definitely to plan already reduced cabinet space in advance. Yeah. And yeah, this will cause a digital twin, which then later on can drive more and more automation in the field when you consider also components ready to robot or the right digital products behind. To summarize the presentation, you should not remember all the details, but what you should take home for your personal project is: start with cleanup, throw off ballast, make you safe, more lean, and like the balloons here on the pictures, lift the ground. Then check the dimensioning. Yeah, take the right glass, the right size of a glass, and not discuss if the glass is half full or half empty. Then define new standards for yourself, for your application. There is no blueprint available. Every application, every cabinet, every design is different, and you can define your own standards. And for sure, we are, as Weitmuller, as a component supplier, we are helpful, but the last decision is with you. And then, if this not helps, go to decentralization, have fun with this. Don't think this is a risk. There is a lot of proven equipment in the market, which will help you to analyze your application and decentralize your functionalities. Yeah, And now we come to the point of question. I will now have a look at the questions. I have to go exit here and check if there are any questions in the chat.
So this is the moderator again. As far as I can see, we have no questions so far, but I suggest to open up the microphones to all participants, so you can ask your questions directly. Let's make this attempt. So feel free to ask questions. No, this will not be part of the recording that will be published afterwards. So now everybody should be unmuted. No, not yet. No, it doesn't work. It seems to have been defined by my colleague per default, and I cannot override it. I'm sorry about that.
Okay. Yeah. Using this, maybe a small advice while you're thinking about your question. When you check this QR code, you will end up on our Connectivity Consulting landing page, where you find more details about the service of Connectivity Consulting, and also the contact formula, where you can get in direct contact with me and my team. So if you, in case this was too fast for you, or you want to ask a particular special question, you can get back to me or my team, my global team, for any support on this. Yeah, I would say, Klaus, if there are no further questions, I thanks on behalf of the Smart Cabinet Building initiative to join this webinar. There are some slides. Yeah. In case you want to contact one of the other partners in the network, like for example Zuke and Comax, Armbus, or Invent Group, here are the contact details. Based on the digital twin, you can drive a lot of more digitalization and automation in your factory. And last but not least, the small advice on our webpage, and also about on the upcoming webinars. As already mentioned, this webinar from today will be available as download, so you can inform your colleagues if they are interested. And in May, we will have a webinar about the new Zeta 620 from Comax. So please feel free to dial in into this webinars and check the content and what is in for you. I can say again, thank you for joining this webinar. I hope you get a lot of information out of this. It was helpful. For me, it was a lot of fun. And this is the word for the end. Yeah, I would say goodbye and stay healthy.